You all know me as Max. This is the presentation of my thesis and what I've done so far on it. A review of head-to-head competitions implied in cranial pathologies in mosasaurs. Oh, So my research question overall is, can behavior be interpreted in the fossil record? And this is something that a lot of publications have tried to do, and a lot of publications have rather well supported, but nobody has, I think, conclusively answered this question. So my co-advisor, Dr. Caleb Brown, actually in 2021 and 2022 worked on a paper on tyrannosaur face pathologies, and he concluded that these pathologies were actually bite marks from other tyrannosaurs. He found that these were on adult tyrannosaurs, and this was actually conducive with what is seen in a lot of modern reptiles like the American alligator and Chinese water dragons. But these face scars, these face pathologies, are actually observed on another group of animals commonly, the mosasaurs. So mosasaurs are actually a group of marine reptiles. They're not dinosaurs, they're actually true lizards. And throughout the literature, there are multiple references to these pathologies on mosasaur skull bones. So as I go through and talk about what I'm doing here, I want you to understand what a mosasaur is. It's this animal here that you can see actually attacking another one. I don't want that to necessarily affect your interpretations, though. So I have a few research objectives that I want to go through. I want to establish a framework for improving certainty in identifying injury pathologies on fossils, survey pathologies present on mosasaur skulls, use statistical methods to identify the trends in mosasaur cranial pathologies, and interpret data for conclusions about mosasaur behavior, ecology, and bone biology. So we're going to actually start with one part of this overall project. There are two parts. So I start with the literature survey. That's what I'm going to actually talk about largely today. And a little bit later on, I'm going to comment on what I'm going to do next, which is that statistical survey. But currently, I basically just looked at all of the literature that referenced uh, marks on mosasaur skulls that they attributed to aggression between members of the same species of mosasaur. So we're going to start with a first hypothesis. So the null hypothesis that I have here is that injury pathologies cannot be distinguished from other features on mosasaur skulls. Well, what do I mean by other features? So actually, I want to start by actually defining what bone remodeling is. You are all geologists, and maybe your biological backgrounds are not the most complete, but so I want to define remodeling. So remodeling is actually maybe more colloquially referred to as healing on bone. So this is where bone has been damaged and is basically regrown. Remodeling actually happens naturally on all bones throughout the course of an individual's life, and that's what we call normal remodeling, and that's where bones would just kind of resorb themselves and replace that bone with just normal bone. It looks exactly the same as the original bone, but then you've got abnormal remodeling, which results from damages or infections, and abnormal remodeling is what we are going to focus on, actually. So that will appear as swollen, raised bone that seems to interrupt the normal smooth bone surface. So we want to actually establish a framework for identifying when we are looking at remodeling as a result of damage to the bone. So we will call these injury pathologies. So as you can see on this figure, there are a few different forms of features that I would be looking at that could potentially indicate something or potentially not indicate something. We have examples up at the top where there might not be any remodeling, and so we wouldn't strongly consider that, but more towards C through F, where we see partial remodeling to complete remodeling, we would expect an animal to have survived whatever damage that it accrued. So to start off, there is one feature that maybe looks a little bit like a pathology, but it's actually not part of the fossil at all. That would be sediment incrustation. So these sediment incrustations can be identified by the fact that they are not made of bone, but sometimes they can appear as bone or at least similar in color. So we would look at those as being something that is erratic and rough maybe doesn't seem biological in texture. Um, Next, we would look at bioerosion. So bioerosion would be any example of where animals were eating away at the dead bones, and sometimes these bioerosion features can look rather similar to pathologies if you're not really familiar with the concept of remodeled bone. But a lot of the time, this will be where bone is missing rather than where bone has been re-added. So the way that we would avoid looking at something as bioerosion is that it would lack remodeling of the bone. Then we'll find damage to fossil bone where remodeling is not present. So when remodeling is present, we would assume that trauma would be antemortem, which means that the trauma happened before the animal died, which means that it had a chance for those bones to heal. But paramortem and postmortem trauma, that being trauma that happened near to or at the time of death or after the time of death, will not likely exhibit much healing. And so we would avoid antemortem trauma when trying to make our interpretations about paleopathologies. And in fact, mosasaurs are known to occasionally cannibalize, but it's not known whether that they would predate on each other or whether this was scavenging. And so any interpretations based on what might appear to be marks from another mosasaur that have not healed on the skull of a mosasaur, you couldn't say whether that was an attack that happened that killed the animal or if it happened as a result of scavenging. There's just no certainty in that. And then you've got features that might be mistaken for pathology because they are very clearly bone, but they seem to interrupt the features of the normal bone. But when we see this in positions where we see bone on every individual of the same species or closely related taxa, we can say, oh, okay, this placement consistently across all of these specimens means that this feature is anatomical. And finally, disease pathologies, which actually will appear as remodeled bone itself, but it'll be erratic, it'll more appear as this bone mass. So oftentimes this can occur from a, a biological driving force, like cancer or like bacterial infection, but this would not always be the result of an injury. So we have a framework that is a question-based framework that we can use to establish when we are looking at an injury pathology. So number one, is the feature part of the fossil? And if the feature is part of the fossil, we can exclude sediment and crustation. Does the feature show evidence of remodeling, healing, or bone structure? And if that's the case, we can exclude both bioerosion and unhealed damage to the bone. Does the feature show up in the same place on most or all members of the same species and or related taxa? And if the answer is no, then we can exclude its possibility as anatomical. And can the feature be associated with apparent breaks, fracture, puncture, or drag, or does it appear as a random mass of bone? And if it can be associated with breaks, fracture, puncture, or drag, we can say that that is in fact a pathology that is associated with injury. So now that we have our way of knowing where there is injury pathology on bone, I would like to point out two occurrences in particular in the literature that cited aggression from mosasaurs on other mosasaurs that do not meet all requirements, and in particular, they do not meet the third requirement, they do not meet the second requirement, which is that they don't show evidence of remodeling or healing. So that would be this mosasaur skull here with all of these seeming scratch marks on it, and then a brain from a mosasaur that has a chip of bone in it. Both of these features were attributed to attacks by other mosasaurs, but because of the lack of healing, it is dubious. You cannot totally say that this happened while the animal was alive and was the result that killed it. Just for the sake of argument, I am going to include this in my data set. So there's going to be two versions of data sets, one that includes these and one that excludes them. Hypothesis 1 is alternate. The injury pathologies are distinct and recognizable on fossil mosasaur skulls. Hypothesis 2, injury pathologies are evenly distributed on published mosasaur skulls. So actually, it looks like published morphology or published pathologies are not evenly distributed. They're actually oriented most heavily towards the front and the top of the skull. So the bones in the back are actually relatively absent of these bone pathologies. So it seems like um, we actually support our alternate hypothesis again. Injury pathologies show a bias in distribution on published mosasaur skulls. Moving forward to hypothesis 3, injury pathologies on published mosasaur skulls show no consistency in orientation, but we actually find that to not be true. Mosasaur pathologies that are on the side of the skull, the lateral faces, actually orient towards the front of the skull, whereas pathologies seen on the top of the skull dorsally actually orient laterally towards the sides of the skull. So we actually see drag that points in certain directions of these pathologies. And hypothesis 3, injury pathologies on published mosasaur skulls in literature show clear trends in orientation, is our alternate hypothesis. Uh, Hypothesis 4, there is no left-right lateral bias in frequency of injury pathologies in mosasaurs in literature. There actually is a small left-right lateral bias. So actually, if you look here, when we account, even when we only account for mosasaurs that exhibit bone remodeling, we still see a small right-hand lateral bias. And so we do on the drag on dorsal pathologies. So our alternate hypothesis is supported. There is a right lateral bias of injury pathologies on mosasaurs in the literature. Hypothesis 5, all mosasaur taxa show equal frequency of injury pathology in literature. So the common taxa that we see are in literature that exhibit these pathologies are Mosasaurus, Tylosaurus, Plioplatycarpus, Prognathodon, Thalassatitan, Platycarpus, Cleidastes, and Pleurodons. So in each of these, you actually would see multiple species. I would like to define that the Mosasaurus, Prognathodon, Thalassatitan, and Cleidastes are all members of the subfamily Mosasaurinae, and the Mosasaurines are actually seemingly the most common members of the Mosasauridae that possess these cranial pathologies that we would associate with injury. This is across 8 total genera, as I listed there, A through H. 4 subfamilies total exhibit them. It's actually totally absent in publication for the Tethosaurinae and Jaguarosaurinae. The Tylosaurinae, like I said, there are some questions on certain tylosaurs. The Plioplatycarpinae, it is rather rare. There are 2 publications that show pathologies for individuals in the Plioplatycarpinae, and then the Halosaurinae is only in 1 specimen of Pleurodons. So our hypothesis 5 is alternate. Injury pathologies in literature are more common in certain mosasaur taxa, in particular the mosasaurines. And finally, I want to go through very briefly my second part, which is what I'm going to do from here on. And that would be the statistical survey of mosasaurs from museum collections exhibiting similar features to those seen in publication. So to do this, and I've actually started, I will be traveling around the United States and Canada to different museum collections and university collections to observe mosasaur pathologies on mosasaur cranial bones unbiasedly. So I'm actually going to be taking data on bones that lack these pathologies and bones that include these pathologies. And I've actually started. I've already visited the Mississippi Museum of Natural Sciences. I've already exhibited the Royal Saskatchewan Museum, the Royal Tyrrell Museum, the Canadian Fossil Discovery Center, the South Dakota School of Mines and Technology Geology Museum, and the Timberlake and Area Museum. I do have several more museums to visit from there on. In particular, I am going to revisit the Canadian Fossil Discovery Center, the South Dakota School of Mines and Technology, the Timberlake and Area Museum, and the Royal Tyrrell Museum. The focus of my literature survey will be actually on the bear paw formation, but I am taking data on mosasaurs from every Western Interior Seaway formation that I can get access to, and I'm going to use the bear paw formation actually as a control environment. So we're going to look and see how common it is within one formation, which would be this one contemporary sort of environment. And I use contemporary loosely because this would be over the course of something like 1,000,000 years, but this is much more contemporary than if I were to say compare it, Niobrara and Pierre and Bearpaw all together, because then you've got several million years that this would be spanning. But I will be using that as the control group and then look at the larger taxonomic implications based on that. Thank you, and I will take questions from my imaginary audience.